Okay, so what we're doing here is measuring the shoe float. Okay, so we set from 0 and then we push the skirt and then record the max float, so the shoe float. So that's how to measure the shoe float. Okay, now why we measure the shoe float? So the shoe and the piston are not one assembly, they're two pieces. So before the shoe, before that shoe come off from the skirt, okay, you have to measure the float if it is in the spec before that happen. So otherwise, if you put it and then out of spec, then it will come off. So it's dangerous. So here, Ari, all right, this one is the drawing of a piston. So this is your barrel here, the cylinder. Okay, this is the slipper plate. Okay, where the piston run. Okay, this is your piston. So here in the piston itself, or in the slipper piston shoe, okay, or piston slipper, this one here, there's a various or many forces acting. Okay, the main force is the on the chamber. Okay, displacement chamber. This is where you displace your oil. So imagine this is the pressure side, so the force here. So this is a displacement chamber pressure force. That's the highest force. Of course, because this is open, that will carry out here. In this portion here, where your ball and slipper, okay, you have a clamping force. So what happened there is, from there, this is your centrifugal force as the piston rotate. So of course, there's a force acting on that shoe through this ball. Okay, so this force here is called a clamping force. Clamping because this ball here, there's a force here. Okay, that will clamp to your slipper on the wall side. All right, as the piston rotate, okay, of course there's a centrifugal force. Okay, so that will act on that slipper. Also, there's a holding force. Holding force where the slipper piston retainer. The piston retainer is hold the, you know, there's sometimes this is a piston plate and then there's a spherical there. Okay, and then your shaft. Okay, that is your shaft. So that holding force is again another force to hold the slipper of the piston. Now what happened, because the piston is a reciprocate discharge and suction. Of course, because this is an angle, the slipper plate is angle, as it goes to the pressure, it will the skirt position is on the top, because you have a holding force that will give stress to the piston shoe. Also, during suction, during go down, as the piston skirt sucking oil, there's a force also, a counter force vacuum. So again, that slipper plate is also holding the shoe. Now, time and time, as the piston work, this will worn out because of the forces acting on this shoe. Now, mainly where that force came from? In this chamber. Okay, that is the largest force that act on the slipper. So that's why we check the float between the slipper and the ball. Because if that is too much float, then when it is operation, they suddenly will come off as the piston reciprocate because of the forces acting on the slipper, then it will fail. So we avoid that happen. So that's why we check the shoe float. Okay? That's good.